When you look up at the night sky, you might see a bright reddish star. That's not a star at all, it's the planet Mars. People have called it the red planet for a very long time because of its special color. This color comes from something you might have seen on Earth. It's the same stuff that makes an old nail or a forgotten bicycle turn reddish brown. That's right, it's rust. The entire surface of Mars is covered in a fine rusty dust. This dust gets kicked up into the atmosphere, which is why the whole planet looks red from far away. It's a planet-wide case of rustiness, and that is scientifically amazing. So what is rust, really? Let's consider this. On Earth, rust is what happens when iron gets wet. It's a chemical reaction, which is a fancy way of saying that different things mix together to make something new. When iron sits in water and is also exposed to oxygen from the air, it changes. The iron, oxygen and water molecules all link up to form a new substance called iron oxide. That's the scientific name for rust. It's a slow process, but over time it can turn a shiny piece of metal into a crumbly, reddish-brown mess. The key ingredients are iron, oxygen, and most importantly, water. Now let's think about Mars. The planet is covered in iron-rich rocks. We know this because our robotic explorers, like the rovers Spirit, Opportunity, and Curiosity, have studied the soil and rocks up close. They have found lots of iron. We also know that Mars has some oxygen, though not nearly as much as Earth. So, we have two of the three ingredients needed to make rust iron and oxygen. For a long time scientists wondered about the third ingredient. If Mars is covered in rust and rust needs water to form, then where did all the water go? This simple observation led to a huge question. This is where the science gets really exciting. The presence of so much rust on Mars is like a giant signpost pointing to its past. It's a clue left over from billions of years ago. It tells us that the third ingredient, water, must have been there at some point. You can't get that much rust without a whole lot of water. This means that the dry, dusty Mars we see today was not always like this. The rust is like a fossil, a remnant of a different time. It strongly suggests that Mars was once a much wetter and perhaps warmer world than it is now, which completely changes how we think about our planetary neighbor. Scientists didn't just guess that Mars had rust, they sent amazing robots to check it out. Spacecraft orbiting Mars used special cameras and tools to map the surface. They confirmed that the red material was indeed iron oxide. Then, rovers landed on the surface to get an even closer look. These rovers are like robotic geologists. They have drills to break open rocks and tiny laboratories inside them to test what the rocks are made of. When they analyzed the soil and the inside of rocks, they found even more evidence of rust and other minerals that only form in the presence of water. It was a groundbreaking discovery, right there in the Martian dirt. One of the most incredible finds was something called blueberries. No, not the kind you eat for breakfast. These were small, round rocks that the Opportunity rover found scattered all over the ground in one area. These little spheres were packed with an iron-rich mineral called hematite. On Earth, this type of hematite sphere almost always forms in water. Finding them on Mars was like finding a seashell on a desert mountain. It was a clear sign that liquid water was once there, soaking the ground and slowly forming these strange little pebbles over a very long period. It was a eureka moment for the science team. The rovers also found layers in the rocks. Think about a cake with different layers of frosting and sponge. The rock layers on Mars tell a story, just like the layers of a cake. Some of these layers could only have been formed by sediment settling down at the bottom of a lake or a sea. The rovers saw clays, which get soft and form in water, and sulfates, which are minerals often left behind when salty water evaporates. These layered rocks are like a history book for Mars. Each layer tells us about a different time, and many of those pages say, water was here. It wasn't just a little bit of water, it was enough to create huge geological features. Putting all these clues together paints a very clear picture. The widespread rust, the hematite blueberries, the clay minerals, and the layered rocks all point to the same conclusion. Mars was not always the cold, dry desert we see today. Billions of years ago, it had water. There were likely rivers that carved the canyons we can still see, lakes that filled the craters, and maybe even a vast ocean that covered a large part of its northern hemisphere. The rust is the most visible clue, the one we can see from millions of miles away, but the evidence on the ground confirms the story. Mars had a watery past. So, if Mars had oceans, what were they like? Scientists have an interesting idea about this. While the planet had liquid water, it was also much farther from the sun than Earth is. The early sun was also not as bright and warm as it is today. This means that even with a thicker atmosphere, the surface of Mars was probably very cold, so any large body of water, like an ocean, would not have been a warm, tropical sea. Instead, it would have been frigid, likely hovering just above the freezing point. Think of the icy waters of the Arctic Ocean here on Earth, but even colder. To understand how water could exist in such cold temperatures, scientists looked at the chemistry. They figured out that the Martian atmosphere back then had a lot of oxygen but not much of another gas called hydrogen. This specific mix of gases changes how rust forms. Through experiments in labs here on Earth, scientists tried to recreate the conditions of ancient Mars. They discovered that to form the types of rusty minerals found on Mars in that kind of atmosphere, the water would have to be extremely cold. If the water had been warm, it would have created different kinds of minerals. This idea of a freezing cold ocean also helps to explain something else. If Mars had a lot of water, why didn't it have a stronger greenhouse effect to warm it up? Some gases, like carbon dioxide, trap heat and warm a planet. But the chemical reactions that were happening on Mars might have used up a lot of those warming gases. For example, the reactions that formed iron and other minerals in the water could have pulled carbon dioxide out of the atmosphere. This would have made the atmosphere thinner and colder, creating a cycle that kept the oceans on the verge of freezing over completely. It was a delicate and very cold balance. So, we can imagine a very different Mars. Picture a world with a vast dark ocean under a pale pink sky. The water is so cold that icebergs are constantly breaking off from glaciers at the shoreline. The waves that crash on the beaches are slushy and filled with ice. It's not a place you'd want to go for a swim, but this cold, oxygen-rich water would have been perfect for creating the rust we see today. It's a strange and alien version of an ocean, but it's the one that the scientific evidence points to, a wet, rusty, and freezing cold world. Understanding Mars's past is not just about learning history, it's about searching for life beyond Earth. Water is the one thing that all life as we know it needs. So, if Mars had oceans, even icy ones, it's possible that life could have started there. Simple, tiny life forms like microbes might have been able to survive in those cold, mineral-rich waters. On Earth, we find tiny organisms living in some of the coldest places imaginable, like deep under the ice of Antarctica. Perhaps something similar happened on Mars. The search for water is always the first step in the search for life. These discoveries also help us plan for the future. When we eventually send humans to Mars, we will need resources to help them survive. The most important resource is water. Knowing that Mars once had a lot of water gives us hope that we can find some of it still there, frozen underground or locked away in minerals. Future missions, like NASA's Artemis program, which aims to return to the Moon and then go to Mars, will carry drills and equipment specifically designed to find and extract this ice. Finding water on Mars would be a game-changer for human exploration, making long-term stays possible. Furthermore, studying how Mars changed from a wet planet to a dry one can teach us important lessons about planets in general, including our own. What happened to Mars's atmosphere? How did it lose all of its surface water? Answering these questions helps us understand how planets work and how they can change over time. It gives us a better appreciation for the delicate balance that makes Earth such a perfect home for life. Mars serves as a cosmic laboratory, showing us what can happen when a planet's climate changes dramatically over billions of years. In the end, every piece of rust and every layered rock on Mars tells a story. It's the story of a world that was once much more like Earth. It pushes us to keep exploring, to send new rovers and one day, people. The next big discovery could be finding ancient fossilized life in those old lake beds, or tapping into a hidden reservoir of underground ice. The rusty red color of Mars is not just a pretty feature, it's an invitation. It's a clue that beckons us to come and uncover the rest of its incredible story. Consider that.